This is a continuation of Chapter 2 from BTC Tutoring on graphs. We're going to look at histograms and box plots. Histograms are used to display the distribution of a quantitative variable. Box plots are also used to display the distribution of a quantitative variable and to show the median and outliers of a data set. Researchers view these graphs to look at any skewing of the data along with any outliers. Our learning objectives in this section is to know how to find the minimum value, the first quartile, the median, the third quartile, and the maximum value. We're going to calculate the interquartile range and find the upper and lower fences of the box plot and find out if there are any outliers. We're going to use the TI 83 and 84 to create box plots and histograms. The key terms in this chapter on graphs, we're going to look at the median. The median is the middle observation of a sorted data set. The location of the median is found from an ordered data set by numbering the ordered data set from 1 to n, and then the median location is n plus 1 divided by 2. If the location is a fraction, we take the number above the fraction and add it to the number below the fraction and divide by 2. The first quartile is a value in an ordered data set where 25% of the data is below the first quartile. The third quartile is a value in an ordered data set where 75% of the data is below the third quartile. The interquartile range, this is the difference between the third quartile and the first quartile. The interquartile is used to calculate the fences for the box plot. And finally, the term fences. An upper fence is used to determine the potential largest value for the box plot, and a lower fence is used to determine the smallest value for the box plot. Any value of the data set outside the fences is considered an outlier. So now we're going to do an example data set, and we're going to find the 5-number summary, which is in order to create the box plot by hand. And the 5-number summary is the minimum value, the first quartile, the median, the third quartile, and the maximum. So in our data set, college students were asked how many hours of sleep per night each student gets during the school term. 50 students were randomly surveyed, and you can see the table below in green. And the x value is the amount of sleep hours per night. That's our variable x, and it goes from 4 to 10. And the frequency values for each of these hours is 2, 5, 7, 12, 14, 7, and 3. To calculate the minimum value by hand, we just look at our table, and we can see that the minimum value of our table that's already ordered for x, the minimum value is 4 hours, and the maximum value is 10 hours. The median location, since there were 50 students that were asked, I'm going to add 50 plus 1, that's our formula, divided by 2. And that gives us 25.5. So we count in our frequency column 1 to 25, or up to 25, and we get 2, 5, 7, and 12, and that's 26. So therefore, where our frequency is at the 12 stage has to include the 25.5 as well as 25. So guess what? Our median has to be 7. Then for the first quartile is the 25th percentile. Thus, the L1 location is 0.25 times n plus 1. And in this case, it's 0.25 times 51, which is 12.75. And again, we count from 1 to about 13. So when we do that, we go 2 and 5 is 7, and another 7 is 14. So guess what? Our first quartile has to be where x is equal to 6. Finally, on the third quartile, the 75th percentile, the third quartile location is 0.75 times n plus 1. 0.75 times 51 is 38.25. And we can count from 2 all the way up to 14, and we will find that in fact the third quartile is 8. So therefore, our 5-number summary is the following. The minimum is 4, Q1 is 6, the median is 7, Q3 is 8, and the maximum is 10. So we're going to create the box plot using the following steps onto an x-axis. We're going to still use the same example data set that we used before, and it's over on the left side of your screen. We're going to find the interquartile range. The interquartile range is Q3 minus Q1. In this case, it's 8 minus 6, which equals 2. We're going to find the lower fence value, which is Q1 minus 1.5 times IQR. In this case, it's 8 minus 1.5 times 2, which is 3. And to find the upper fence, we use Q3 plus 1.5 times IQR equals 8 plus 1.5 times 2, which is equal to 11. And then we locate any outliers in this case. And in this case, because our fences are 3 and 11, we don't have any outliers. X doesn't go below 4, or it doesn't go above 10. So therefore, we can draw, in this case, we can draw our box plot. And here it is. We have the median at 7, and we draw a line there. There's our median. And then here's Q1, and here's Q3, and so we draw a box around that. And here's the upper fence value. So we get the upper fence, which is 11, but the only value that's below the fence, that's our nearest whisker, we call it, is at 10. And we do the same thing for the lower fence, right, which is 3, but the lowest value is 4, so we go ahead and put that value in. So there's our distribution for the box plot. In this slide, we're going to show you how to actually do the box plot using your TI 83 and 84. We are going to use the same data set that we have been using in the previous slide, which is the sleep hours. And so the first step that we're going to do is we're going to turn the computer on, and then we're going to hit my stats key, and we're going to hit edit, and we're going to make sure that the data that's in our table are in L1 and L2. Then we're going to hit the second key and then the Y equal key. We're going to hit the plots on, and then we hit enter again to make sure that we're on this particular plot. Then we're going to move using the cursor over to where the box plot is. We're going to hit enter. The X list is going to be L1, and the frequency list is in L2. And you'll see I hit the second key and the 2 key. And then I'll hit enter, and I'll leave those alone. I'm going to then hit the Windows key, and now I'm setting up my x-axis. So I notice that the lowest value is 4, but I'm going to go ahead and use 0 for my minimum value so I can see the box plot. My maximum value, I'm going to set 12 because I have 10 as my maximum value, but again, I want to see my box plot. So I hit the scale 1. The minimum value I'm going to leave as 0, and for y minimum, and then y max is 10. Then I'm going to hit graph, and there is my box plot. Technically, I can use the arrow keys to actually get the values. So finally, we're going to show you how to do a histogram on the calculator. Again, we're going to use the same data set, and we are going to go ahead and show you how that works. So on the calculator, again, we use the stats key. Make sure that the data is in L1 and L2, just like your table is. L1 is your X variable, and L2 is your frequency. You're going to hit the second key and then the Y equal key, and again you have plots on. We make sure that the plot is on, and we're going to come over to where the little histogram is. We make sure that the X list is in L1 and frequency list is in L2. We hit the windows. We're going to leave the X values from 0 to 12 and our scale 1. But now for the Y minimum, we're going to go up to maximum of 20. And we're going to put 2, 0 in. And then our scale is going to be 2. And so now we're going to hit the graph key, and you'll see our histogram. It looks rather normal, right? So that's it. And again, you should be able to use your arrow keys to get values, and I'm not sure why it's not working in this particular case, but it should show you the values on your screen. That concludes our Chapter 2 on graphs and using the TI 83 and 84. And next section should be Chapter 3.